I'm going to invite the next speaker that is in line. Everyone is being very good with timekeeping. So I have the honor and privilege of inviting on stage a very dear and good friend, a teacher that fell in the net of Núcleo, the Galileo Teacher Training Program, and Hands-on Universe many years ago, and lucky to us, never left. It's Alvaro Folhas is a very good human being, a friend, and an amazing teacher. And as some people here in the panelist list, who I'm not going to say who, he might be called Alvaro, but that's not his name. His name is Alvaro. He will be presenting space technology, small devices for big achievements. Alvaro, the floor is yours, and I'll let you know when you have 5 minutes left, so you can decide to go for questions, interacting with the audience, and continue your presentation. So please, the floor is yours.
Thank you, Rosa, for the introduction. I suppose I don't have the... I'm mute? No.
You are not mute, no?
No? Okay. Thanks for the introduction. You are too kind, as usual. My talk today is about how to use astronomy to teach science in interdisciplinary sense, using small do-it-yourself devices to help improving scientific literacy and several competences and soft skills. I'm going to share my screen. Suppose this. Okay. Sorry. I have to. It's okay, like this.
Perfect.
Okay. So, what the OECD Education 2030 Future of Education and Skills projects intend to support countries finding answers to two far-reaching questions. Children who enter in schools in today will be young adults in 2030. Schools are facing increasing demands to prepare students for a rapid economic, environmental, and social changes, for jobs that have not been created yet, for technologies that have not been invented yet, and to solve social problems that we don't have yet anticipated. So, OECD Education 2030 aims to build a common understanding of the knowledge, skills, attitudes, and values necessary to prepare the future towards 2030. To do that, we need to define a clear vision and goals for education system, a common and large language for countries, and we have to engage students to science, help them to acquire knowledge and develop attitudes and skills to respond to the challenges of the future. Where is... Okay, how to do this? So, we know students are running away from schools. They don't interest for science. So we have to challenge, we have to surprise it, and when we involve students to science, to fulfill what we desire for the future. The subjects must be appealing, must be hands-on and minds-on proposed, must be involved, must involve the student, must be related to everyday life, must be interdisciplinary, because life is interdisciplinary. We have to approach the contents of the school to our life, to our daily life, to build a sense for a proposal why we must study, why have to learn, and so on. So astronomy is a very good choice because have all these ingredients. So why astronomy at school? Well, we can say the astronomy was the starting point to civilization, because people understand that when these little dots in the skies appears, it begins to rain comes, or the freeze, or something else. So they understand the regularity who runs the cosmos are essential for their life. For that, astronomy has begun to be a part of our civilization, and they must how can I say, from the Paleolithic to Egyptian culture, from the ancient Greece to the discovery of sea routes the Portuguese are doing, and the Spanish also, astronomy has always been a factor in the progress and development of societies and knowledge. Astronomy and space science allow the creation of bridges between science in an interdisciplinary way, understand the phenomena that surround us every day in our lives. Astronomy has also the ability to make us dream, to make us believe in new challenges, in a world was as a whole, without barriers, without lines, without prejudice, just a blue dot in the universe where life happened. This is the level that must sustain all the knowledge. We today, to look further, we can use portable telescopes, remote telescopes, radio telescopes at schools. We can use augmented reality to make the learning experience more vivid. We can also do several tasks like hunting asteroids, explore the cosmos through tools we have at our disposal, provided by ESA, NASA, ESO, Folhas, etc. We may now at school study black holes, study supernova, study exoplanets, etc., to project the future using space sector as a development level. So, what must we do at schools? We must create the appetite for knowledge. We must arouse the curiosity, keep the students awake and challenged. We can do that with some proposals like find errors on pictures to let them discuss the problems, to let think about the problems, to let them achieve the answers to the problems. Today, what I'm going to present here is about some activities with small resources. For instance, we can just with a nail or a large screw and a piece of paper and a ruler, we can mark the position of the shadow of the skies and follow throughout the day and see what it tells us. So to do that, we just have to trace the tip of the shadows, and after that we have to draw a circumference. We intercept this line into points. These 2 points are the axis east-west, and if we draw another line crossing this one, we have the axis south north-south. So with an easy way, we can ask the students, why is that? Why are the shadow in our position in Portugal, for instance, why the position of the shadow in the north? That's because the sun is in the south. So, but that's a way to leverage all the things they watch in everyday life to make some measurements. We can use the shadows also to find the height of several things, the trees, the poles, and several other things, the buildings. We can explore the mathematics involved. We can explore the latitude, the cardinal directions, the time using sundials, the height of the sun, uh, everything without any resources, just with maths, with physics, and with minds-on activities. We can also see why does the trees have the moss always the same side, why the mountains provide us more vegetation in one side than the other. They must look the world in another way. If we want, we also with some stuff they use at classes, we can improve and create some new materials to watch the height of the trees or the buildings using these kind of materials and using the mathematics involved. So we can do that at schools without any difficulty. We can also achieve what is our latitude using this kind of project. We can also find the latitude using mathematical issues and shadows from the sun. We can make some projects with these concepts during months. So the students take some measurements in every day and create tables and create graphs and other stuff to provide the competence and the skills they need for the future. Also, we can, for instance, calculate roughly the height of lunar craters also, with the same way we found the height of the buildings. This is something we can provide easily without any resources, and we can also create another way to do things to provide the interdisciplinarity. We can make one day lesson activity involve several activities, several disciplines, several issues involved. For instance, how may I determine the diameter of the sun? We can do that using two plaques and a ruler. So for that, we have a simple device knowing the distance from the sun to the earth. This method allows us to work the concept of optics, since use a pinhole here, and also some mathematics, very simple, as a similarity of triangles, for instance, or a direct proportionality. But instead of using just one point, we can do another thing. We can create this ruler and move the slide the plaques on the ruler. So that provides us not just one dot, not just one measurement, but several measurements. So with just one measurement, we can also determine the distance with these concepts. the pinhole is here. So the triangle formed on the target is similar to the triangle between the sun and the earth. So they can achieve what is the ratio between the two values. For that, knowing the distance to the sun, we can follow that the distance, the diameter of the sun is 1,050,000 kilometers. But if we do what I said before, if we move the plates, we can reach that we have so the shape is the same, but the size is different. As long as I move, I approach or I put far away the two plates between them. We can use the function, mathematical function, and that's a way to avoid the calibration errors that could affect the previous measurements, and consequently the results. We can improve the process by collecting several points and doing a graphical analysis of the results. This second method, in addition, to provide the more correct results, allow us working with a variety of mathematical concepts and error analysis. So using that, what we use usually in physics to analyze the experiments.
Alvaro, you have 4 minutes.
Okay. So with these results, we can produce a line, a straight line, and this straight line has a slope 0.01. So the result is the same in this case because we don't have an earlier error, but in other cases it could be great. And they understand the subjects between this line, what represents the slope in this case. The results are very good with a very nice approach, but we can also do other kind of activities. For instance, here we have a project which involves several disciplines in work groups. We can follow the Eratosthenes experiment. So everybody knows what is this experiment, but the proposal is not just do that, but create one day action to study this work. So we can use for the first station. We can telling to the students what is the Eratosthenes experiment, the concepts involved. A second station, we can follow the concepts of the equator in geography, the meridians, the latitude, longitude, etc. We can, after, go to the computers and search the local coordinators and the distance between schools and the equator. We can apply the concepts of physics and astronomy, apply after that the concepts of mathematics, and after we can do the real experiment using different kinds of materials, poles, nails, etc., and to achieve what they can do with that. We can also propose to make some artistic dramatization, videos, cartoons, etc. So it's a great approach we can do with this kind of shadows and stuff.
Alvaro, I'm afraid you only have 1 minute left.
Okay. The size of the moon, we can achieve the size of the moon using a simple process with just when an image of the eclipse, we can draw the circumference, and with a ruler we can make the proportion between the size of the Earth here, who provides the shadow, and the size of the moon. With that, we can make the angle and provide also the distance between moon and the Earth. So this is several ways to, without any resources, to provide knowledge to involve students and to learn several things we must do at school today. Thank you, and sorry for the time. I exceeded my time.
Alvaro, that was brilliant. Thank you so much for the presentation. It was really very rich, and you can see all the compliments in the chat. I am sure that you have inspired many of the colleagues here and also watching us online. I will ask you please to put your contact in the chat, because I am sure people will be willing to contact you. And you can still put questions in the Q&A for Alvaro if you'll be willing to do that. That was a brilliant talk, Alvaro. Thank you very, very much. I loved especially the one with the lunar eclipse. That was actually very, very, very nice. But unfortunately, time is limited and we have